Welcome to this video where we are going to solve this problem. But first of all, let me introduce my team. My team is composed by Carol, Montserrat, Javier, and me, Carlos Jacob. Today we are going to solve this problem. The first step, obviously, is that we must read carefully each single word. The problem says, gravel is being unloaded from a truck and falls into a pile shaped like a cone at a rate of 10 feet 3/minute. The radius of the cone base is 3 times the height of the cone. Find the rate at which the height of the gravel changes when the pile has a height of 5 feet. We must first identify those critical points that will help us to solve our problem, the main data. Let's see. It says that it is falling into a pile shaped like a cone. So we remember how a cone is. It's something like this, a cone. We can even draw here a truck that is throwing the gravel to a cone at a rate of 10 feet 3/minute. It says the radius of the cone base, it means this, the radius is 3 times the height of the cone. Find the rate, so let's see that we are being asked to find the rate at which the height of the gravel changes when the pile has a height of 5 feet. Having gathered the main data, we must start solving our problem.
Answering the question that our friends had, we're going to solve this problem. Okay, so first of all, a truck is unloading gravel into a pile shape. So first of all, we need to know what is the figure that is forming, so we can solve the problem. As we can see, here is making a cone shape. So first, we need to get the formula for the cone in order to solve the problem.
First of all, we know that the volume of the cone is 1/3 times pi times radius squared times h. Well, why? We have a cylinder. Inside had a cone, but the cone is not the whole cylinder. So we had radius. This radius had 1/3 because, as I mentioned, it's not the whole, so it's 1/3. Pi because we have the base is like a circle, so it's pi, and the height, I have this height.
As Carol told us, the formula for the volume of a cone is 1/3 times pi times radius squared times height. So now that we have the formula, we need to get the data from the problem. So the problem says that the radius of the cone is 3 times the height of the cone. So if we have the height, the radius is going to be 3 times the height. So radius is equal to 3h. Then we substitute this into the formula, and we get volume is equal to 1/3 times pi times, as it is squared, we have 3h squared times h. And we have volume of 1/3 times pi times 3h cubed. Okay, now that we have this, we can derivate, but we need to make a
How do I perform implicit derivatives? In implicit differentiation, we differentiate each side of the equation with 2 variables by treating one of the variables as a function of one of the other.
We need an implicit derivative to solve this problem, but in here we can simplify things and we can get rid of this 1/3. So we can multiply this 1/3 times pi. We solve this and we get a 9h cubed, and now we can simplify this 1/3. We have volume equal 1/3 pi times, we can make this 9h cubed, we can make it into a 3 times 3h cubed. So we can simplify this 1/3, multiplying this by this 3. So now we have volume is equal 3/3 of pi times 3h cubed. This is equal to 1, so now we have just pi. So now that we have volume is equal of pi times 3h cubed, we can derivate this so we can solve the problem. We're going to use implicit derivative that is already been explained. So we derivate over time, and we get dv over dt. It's equal to pi. We don't derivate it because it's a constant. We derivate this, and we get 9h squared by the chain rule, and we have times the implicit derivative of height, that is dh over dt. Now that we have this, we can get back into the problem again to get some more data. As the problem says, gravel is being unloaded from a truck and it falls into a pile shape of a cone at a rate of 10 feet cubed over minutes. So this is the rate of the volume. So we can substitute this dv over dt into a 10 feet cubed times minute. Over minute, sorry. It's equal to pi times 9h squared over dh over dt. This dh and dt over dt is the variable that we want to get in order to get the rate of change when the height of the gravel changes. So now, as the problem says, we need to get the rate when the cone has a height of 5 feet. So we substitute this h into a 5 feet. So we get 10 feet cubed over minute. It's equal to pi times 9 times 5 squared times dh over dt. So now we don't have another variable. So we get pi times 9 times 25 times dh over dt. And if we simplify this, we get 10 feet cubed per minute. It's equal to pi times 225 times dh over dt. So now we can multiply this pi times this 225. So we get this again. And 225, but we forgot that it's feet. Yeah. So we can multiply this, and we get 225 feet pi times dh over dt. 225 pi feet. Sorry. And now we can simplify this and pass it dividing to the other side. So feet per minute over 225 pi feet. It's equal to dh over dt. And now we can leave it at this, or we can simplify it to 5 over 5. This is going to be a 2. This is going to be a 45. We have the feet simplified, so we get feet squared over minute. It's equal to dh over dt, that is the rate of change of when the height of the gravel changes. Sorry, I missed some things. These feet are going to be square because you're going to square it here in the 5 square. So you have 25 feet squared, and that will give us here isn't feet squared, so it cancels out. So we just have feet, not feet squared, and also I missed the pi. And that's it. Thank you.
Congratulations, we have solved the problem. Now let's review our final result. 2 over 45 pi, and here is one of the most important things that we must always remember. The units, in this case, feet over meters. We can conclude that these are the units based on all the procedures that we previously made. Nevertheless, it's always important to don't forget this part, because if we do not specify the units, our problem will be incorrect. We will not be knowing about what units are we talking about. So please always remember to write the units. Thank you very much, and thanks for watching the video.